Hey everybody, so I made this video for creating a perpendicular bisector using construction. Since a lot of my students have been having some issues, I thought I'd have this as a resource for you guys. So let's start off with this triangle. We are going to create perpendicular bisectors for each side. So perpendicular bisector means it's going to be perpendicular, which means it's crossing at a 90-degree angle. And bisector means it's going to be cut into two equal parts. Okay, so we're doing this to each side of our triangle. So let me start by labeling A, B, C. Okay, so let's start off with AB. What we want to do first is we want to adjust our compass to a little bit bigger than halfway. About here, this is a little bit bigger than halfway, and I'm going to create an arc above and below and do the same thing on the other side. There we go. So if you notice, these cross in two places, right here and right here at the bottom, above and below. So what I want to do is I want to take my ruler and connect those 2 points together to create a straight line. Okay, so this is my perpendicular bisector for AB. So I'm going to create a 90-degree angle here because that's what this is, a perpendicular bisector, and it's cutting this side into two equal parts. So I'm going to put little hash marks to show that this piece is the same as this piece because it's a bisector. Now I'm going to change colors and we're going to do the same thing to BC. Let me rotate my paper here. So we want to bisect BC with a perpendicular bisector, so very similar to before. I'm going to create an arc. Do the same thing on the other side. And I want to see where these two cross. A little short on this side. Okay. So I can tell that they crossed here and here at the bottom. They intersected. So I'm going to draw my perpendicular bisector for this side. Okay. So remember, this is a perpendicular bisector, so I'm going to put a little 90-degree symbol there, and I'm going to put two hash marks on each side now to show that these two pieces are the same because it's a perpendicular bisector. Now we're going to do the same thing for AC. So I'm going to adjust my compass so that it's a little bit bigger than halfway. Make it a little bigger. Create an arc above, below, above they cross here, below they cross there. Let me make this a little bit bigger. Okay. So now I'm going to use black. So they crossed here and here. So this is my last bisector. So again, this is a perpendicular bisector. I'm going to draw my 90-degree angle here, and now I'll put 3 hash marks on each side that show that I cut that piece in half. Now the whole purpose in doing all of this is to see where my red, purple, and black line ended up intersecting or crossing. So they ended up crossing at the same location right here, this point. And this is a point that I wanted to find in the first place. We call this the circumcenter. Okay. So using that center, that point that we found, I'm going to adjust my compass until it reaches one of the vertices of my triangle. So let's go to B here. It doesn't matter if you go from A to the center, B to the center, or C to the center, because all of those measurements should be exactly the same. That's what the circumcenter is doing. So let me draw my circle here. Okay, a little bit off. Okay, so if you guys notice, A, B, and C, the points of my triangle are on this circle. And they're the same distance away because they're on the circle. So it's like the radius from the center to C is the same as the center to B is the same as the center to A. That's what the circumcenter is finding. It's the center of the circle using perpendicular bisectors. Okay, so the circumcenter is found by using perpendicular bisectors to find the point. This is called the point of concurrency. Basically, where all the lines end up meeting. So the circumcenter is also called the point of concurrency, which just basically means where the red, purple, and black line meet, which are perpendicular bisectors for each one.